Hi, I want to talk about the Allee effect. This is an effect where a population that's too small cannot survive. The population needs a certain minimum size to allow its members to reproduce. And then in our case, we're giving this function here to describe the population growth rate, R, as a function of the population level, N here. And I've drawn out the function. It's a cubic function, and it has zeros at n equals 0, n equals 3, and n equals 8. And the question asks us to find the maximum and minimum growth rate on the interval 0, 9. So we want to use the closed interval method because our function is a continuous function defined on a closed interval. And so what we can do then is we look at the critical points and the endpoints. And then we evaluate the function at these points. To find the global max and the global min. Okay, so here's our function R. I'm going to expand it out. And one last line here. So we've expanded it out as a cubic polynomial. And so the next thing we want to do is to compute the derivative and set it to 0. So 0 is r prime of n is equal to minus 3n squared plus 22n minus 24. Okay, we want to find the values of n that satisfy r prime of n is equal to 0. This is a quadratic, so we need the quadratic formula. So recall, if ax squared plus bx plus c is equal to 0, then x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. This quadratic formula is something we need for the course. Okay, we can apply the quadratic formula here, and we get n plus or minus is equal to minus 22 plus or minus the square root of 22 squared minus 4 times minus 3 times minus 24 over 2 times minus 3. Okay, so you can do this on your calculator. I'll just give you the answer here. And you should check this. So we have the lower root is equal to 4 over 3, and the upper root is equal to 6. And so these give our critical points. So we have to evaluate the function at the critical numbers given here and at the endpoints. And so when we do this, we have that r of 4 over 3 is equal to minus 400 over 27. So this is something to try yourself and check. It's a little bit of work to calculate it out. And r of 6 is equal to 36. And r of 0 is equal to 0. And r of 9 is equal to minus 54. So we want the largest of these as our absolute maximum, and it's going to be 36. And so our maximum occurs at n equals 6, and it has a value of 36. And we want to compute the most negative number here, and it turns out to be r of 9, which is minus 54. And so our absolute minimum is at the endpoint 9 minus 54. And so we see here that on this interval, the absolute minimum is at the endpoint 9, and the absolute maximum is at a critical point, which occurs at n equals 6.